Hi students, welcome to my channel. Today I am going to take into the one of the important topic in physics. Before we can go for our actual topic, just we can see about the introduction part. The introduction part, already everyone will be well familiar with light, no? Yes sir, light. For example, what are the things surrounded by me? I am seeing that is because of what? Like for example, I am seeing the marker, I am seeing the whiteboard, or any object near me. That is, I am seeing that is because of what? Light. Now we can say what is meant by light. Yes, what is meant by light? How we can see define light? Light is a form of energy. Yes, it is a form of energy. It causes what? Sensation of sight. Yes, it causes the sensation of sight. We are going to call it what? Light. Otherwise, we can say light is an electromagnetic wave. Yes, light is an electromagnetic wave of wavelength ranges from 4000 Armstrong. Wavelength ranges from 4000 Armstrong to 7000 Armstrong. Okay, any electromagnetic wave of wavelength will be in between 4000 Armstrong to 7000 Armstrong. We are going to call it as what? Light. Yes, sir. You can call it as light. In physics, there will be a separate branch. Yes, there will be a separate branch is there to study about the light. That one we are going to call it as what? Optics. Yes, sir. Optics. Optics. Okay. Optics means is a branch of physics. Yes, sir. It is a branch of physics. It deals with the study of. Yes, sir. It deals with the study of generation. It deals with the study of generation, propagation or transmission. Yes, no, propagation or transmission. Transmission and detection of light. And detection of light. Generation, transmission and detection of light. Simple one. Optics means is a branch of physics. As it is a branch of physics, it deals with the study of generation, propagation or transmission and detection of light. We are going to call it as what? Optics. Now here, again the optics we are going to classify into two types. Optics we are going to classify into two types. First one will be what? Geometrical optics. Geometrical optics. Or we can say ray optics. Geometrical or ray optics. Geometrical or ray optics. Another would be physical optics. Physical or wave optics. Physical or wave optics. Okay, these are the two branches of physics. One will be geometrical optics or ray optics. Another will be physical optics or wave optics. Now here, see I have to explain what is the difference between geometrical optics and ray optics means. I am going to take the few properties of light. First one, reflection. Second one, refraction. Reflection. Refraction. Third one, TIR, total internal reflection. Total internal reflection. Fourth one, scattering. Fifth one, dispersion. Here I am going to take these properties of light. Here I am going to take the few properties of light. First one, interference. Interference. I am going to take second property here, diffraction. And third property here I am going to take polarization. Okay, these are the few properties. Now, based on these properties, I am going to explain see what is meant by geometrical optics and what is meant by physical optics. See here, simple one. Already in school level itself, people study about reflection. That's why study about the reflection. What is meant by reflection? When a ray of light travels from one medium to the another medium, incident on the surface of the another medium. Yes, I am going to be incident on the surface of the another medium. The part of the light is going to be reflected back to the same medium. We are going to call it what? A reflection. Same way, reflection. When a ray of light travels from one medium to the another medium, it changes the path. Yes, the path is going to be changes. That one we are going to call as refraction. Same way, when a ray of light travels from denser to rarer medium, at an angle of incidence will be greater than the critical angle. We are going to call as what? TIR, total internal reflection. At an angle of incidence will be greater than the critical angle. What will happen? Ray will be reflected back or rebounds to the same medium. That one we are going to call as what? TIR. Same as scattering and dispersion. These are the properties. In these properties and all, we are going to assume as. That's why we are going to take as light is going to follow what? Straight line path. That's why we are going to take as light is going to take as straight line path or rectilinear propagation of light. That's why here and all we are going to assume as light is going to follow what? Straight line path or rectilinear propagation of light. Rectilinear. Yes, sir. All the properties we are going to take as light is going to follow a straight line path. T is one. We are going to explain what? Any particle nature of light. Light is going to follow a straight line path means that is going to explain the particle nature of light. Particle nature means any particle. I am going to take a stone. That stone I am going to throw it. What the path is going to follow? Follows straight line. No? These and all is going to explain what? Straight line propagation of the light or rectilinear propagation of the light. That one we are going to call it as geometrical optics or ray optics. We are going to discuss about particle nature of light. Yes, we are going to discuss about particle nature of light. Now here, what are the properties? Interference, diffraction, polarization. Just interference, diffraction and polarization. In interference, diffraction and polarization, we are going to study about wave nature of light. That's why we are going to study about the wave nature of light. Yes, now wave nature of light means the light is going to be traveling in the form of crust and trough. Yes, the light is going to travel in the form of crust and trough. The wave nature of light we are going to discuss. This is about what? Wave nature of light. Here we are going to discuss about particle nature of light. That one we are going to based on the propagation of the light. Based on the propagation of light. Clear? Based on the propagation of the light, we are going to optics. We are going to classify into three: ray optics or geometrical optics. Another will be physical optics or wave optics. Clear? Clear? Yes, and there are two branches of physics. In this branch, few properties are explained by wave nature and few properties are explained by ray optics. No, I'll explain later what is the difference here. I'll explain. Now, the condition for applicability. Yes, the condition for applicability. When you can apply the geometrical optics or ray optics, and when you can apply the wave optics. Here there is one condition. Okay, the size of the interacting particle. Yes, the size of the interacting particle will be greater than the wavelength of light. Yes, greater than the wavelength of light. The ray optics is valid. Okay, the size of the interacting particle will be greater than the wavelength of light. The ray optics will be valid. The size of the interacting particle will be equal or less than the size wavelength of light. Wave optics will be valid. Okay, interacting particle means here it will be simple lens or mirror or aperture or small hole. Aperture or small hole. That are the interacting object. Means when light is going to incidenting object. Interacting object. That one we are going to call it as what? Interacting object. Okay, clear? When the size of the interacting particle or object will be greater than the wavelength of light, the ray optics will be valid. If the size of the interacting particle will be less or comparable to equal to the wavelength of light, the wave optics will be valid. Now, here, see, from this one we are going to conclude that light is going to exhibit the two nature. One it will be particle nature, another will be wave nature. This light is going to exhibit particle nature and wave nature. Here, the so many theories are came to explain the nature of light. So many theories are came to explain the nature of light. In that one, first one is Newton corpuscular theory. Newton's corpuscular theory. Newton's corpuscular theory. Here, the Newton corpuscular theory was proposed by Newton. Newton corpuscular theory was proposed by Newton. According to Newton corpuscular theory, Newton said that he is going to give the few assumptions. Newton said that light is going to be traveled in the form of light consists of. He said that light consists of extremely small tiny particles. Yes, extremely small tiny particles is called as corpuscles. Is called as corpuscles. Corpuscles. Light consists of extremely small tiny particles. Tiny particles is called as corpuscles. They are going to travel in all directions. Yes, they are going to travel in all directions. This is the first assumption. Based on this, we are going to calculate what Newton corpuscular theory. Next, he said that the different colors of the light. Yes, different colors of the light is due to different sizes of the corpuscle. No, there will be different colors of light. No? The different colors of light, that is because of what? Different sizes of the corpuscles. Yes, different sizes of the corpuscle. That is the third assumption given by the Newton. Third assumption given by the Newton, that will be the speed of light will be more in denser medium compared to rarer medium. Yes, more in rarer to denser medium. Yes, the speed of light will be more in denser medium compared to the rarer medium. Simple. For example, when a light travels from air to water. Yes, air to water. Air medium we are going to call as what? Rarer medium. Water medium we are going to call as denser medium. According to Newton, what? Speed of light will be more in water, less in air. Yes, less in air, but that is the main drawback. Drawbacks. That is the first drawback. Speed of light will be more in. Yes, velocity of light or speed of light will be rarer medium will be greater than denser medium. But according to Newton corpuscular theory, the speed of light or velocity of light will be more in denser medium compared to rarer medium. That is the one drawback. Okay. Next, here this theory successfully explains reflection, refraction, TIR and all. Is going to explain the successfully explain the reflection, refraction, TIR and all. But this one fails to explain. Yes, this fails to explain interference, diffraction, and polarization. This is going to be fails to explain. This is about what Newton corpuscular theory. Okay, here simple one. There are so many theories are going to explain the nature of light. In that one, first one Newton corpuscular theory. The Newton corpuscular theory was proposed by Newton. According to this theory, Newton said that light consists of extremely small, tiny particles. This called as what? Corpuscles. They travel in all directions. Now, the different colors of the light is due to different sizes of the corpuscles. Next, according to this theory, velocity of light will be more in denser medium compared to rarer medium. This explains reflection, refraction, TIR, scattering, and all is going to be explained. But failures it will be simple. The velocity of light actually will be more in rarer medium compared to denser medium. Next one, it fails to explain interference, diffraction, and polarization. Next theory, second theory, Anil's wave theory. Anil's wave theory. Anil's wave theory. Here, the Anil's wave theory is proposed by Anil. Anil's wave theory is proposed by Anil. Here, he also made few assumptions. Okay, he also made few assumptions. According to Anil, light is emitted from the source. Yes, light is going to be emitted from any source is in the form of wave. In the beginning itself, he said that light is emitted from the source will be in the form of wave. Yes, it will be in the form of wave. Then one more assumption is here. The light is going to be traveling in a medium, no? Yes, the light is going to be traveling in a medium, no? That medium is called as ether medium. Is given as ether medium. Light is traveling in a medium is called ether medium. Another one, light is emitted from the source in the form of wave. Yes, emitted in the form of wave. Clear? Yes, emitted in the form of wave. These are the few assumptions was given by the Anil. Okay, simple. For these two, we have to remember light emitted from the source itself is a wave, and there will be medium in which light travels is called as what? Ether medium. Here, few drawbacks. First one, ether medium does not exist. Ether medium does not exist. Ether medium does not exist. There is a separate any medium that light which can travel, but the speed will be changes. No, that's why ether medium does not exist. This theory explains reflection, refraction, interference, diffraction also explains. That's simple. Earlier it fails to explain interference and diffraction, polarization. But here it explains reflection, refraction, interference and diffraction. But it fails to explain. Photoelectric effect. It fails to explain photoelectric effect, Compton effect, photoelectric effect, Compton effect, and black body radiations, etc. Black body radiation, etc. These properties can be explained by the Anil's theory. Clear? Here it will be interference, diffraction is what. Here it explains interference and diffraction, but fails to explain photoelectric effect, Compton effect, and black body radiation. Therefore, next theory, the third theory came. Maxwell's electromagnetic theory. Maxwell's electromagnetic theory. Here, Maxwell assumed that, Maxwell is going to assume that light is an electromagnetic wave. Light is an electromagnetic wave. Maxwell assumed that light is an electromagnetic wave. Clear? Light is an electromagnetic wave. For example, here Maxwell is going to say that light is an sinusoidal vibrations of electric and magnetic vibration. Sinusoidal vibrations of electric and magnetic perpendicular vibration. For example, this will be electric vibration, another will be magnetic vibration. The sinusoidal vibration of electric and magnetic, mutually perpendicular electric and magnetic vibration, and also perpendicular to the direction of propagation of light. This is electric vibration, this will be magnetic vibration, this is the direction of propagation of light. This was explained by Maxwell. Light is an electromagnetic wave. This is a sinusoidal electric and magnetic wave, mutually perpendicular electric and magnetic vibration, and also perpendicular to the direction of propagation. Direction of propagation. Okay, this is the assumption given by the Maxwell. Same way is going to be said that the electromagnetic waves are going to be emitted from accelerating particle or accelerating charges. Electromagnetic waves are going to be emitted from the accelerated charges. It also explains interference, reflection, refraction, diffraction and all. But drawbacks. It fails to explain photoelectric effect, Compton effect, etc. It fails to explain photoelectric effect, Compton effect, yes. But it explains interference, reflection, refraction, okay, diffraction, polarization and all. This is polarization and all it explains, but it fails to explain photoelectric effect and Compton effect, etc. Next, one more theory came. quantum theory. Planck's quantum theory. According to this theory, Planck assumed that light consists of packets or bundles of energy. That's why light consists of packets or bundles of energy. The energy of the light is given by E is equal to h. H is the Planck's constant and mu is the frequency. Simple one. Light consists of packets or bundles of energy is called Planck's quantum theory. This is Planck's quantum theory. This theory is also able to explain. Again, this theory is able to explain. Okay, quantum nature of light. Yes, the quantum nature of light. The quantum nature of light means it is able to explain interference, diffraction, polarization, and all. But here it fails. It fails to explain interference. It fails to explain interference, diffraction, and polarization. Okay, according to Planck's quantum theory, we are going to explain quantum nature of light means it explains photoelectric effect, Compton effect, and black body radiation. But it fails to explain again interference, diffraction, and polarization. Okay, light consists of packets or bundles of energy. Energy of the light is given by E is equal to h nu. But it explains Compton effect, photoelectric effect, and black body radiation. But it fails to explain interference and diffraction and polarization. See, in all the theories, all the theories, the few properties can be explained and few properties cannot be explained. Clear? In some theories we can explain the particle nature of light. Some theories we can explain the wave nature of light. Yes, sir. All the properties we can't explain in any theory. That's why we can conclude that light is going to exhibit dual nature. That's why light is going to exhibit dual nature. Means sometimes light is going to exhibit the particle nature and sometimes light is going to exhibit the wave nature. Yes, light is going to sometimes is going to exhibit the particle nature and sometimes is going to exhibit the wave nature. Clear? Yes, based on these theories, we can't explain all the properties in a single theory. That's why we can conclude that light is going to exhibit the dual nature. Sometimes it's going to exhibit the particle nature and sometimes it's going to exhibit the wave nature. That's why in our syllabus, in part 2, in our second year syllabus, in part 2 textbook, first chapter will be geometrical optics. We are going to study about only particle nature of light. Yes, we are going to study about particle nature of light. In second one, we are going to study about the wave nature of light. Yes, wave nature of light. Next chapter will be there, dual nature of matter and radiation. In that chapter, we are going to study about dual nature according to de Broglie equation and de Broglie explanation. We are going to tell that light is going to exhibits both particle nature and wave nature. Clear? Yes, and here we are going to study about particle nature, wave nature. Finally, we are going to conclude that light is going to exhibit dual nature. Now, for the explanation I given here, in this one, I am going to take you to the wave nature of light. Next class onwards, we can discuss about the wave nature of light. Clear? The particle nature is going to explain by one more person. I am going to explain about the wave nature of light. Clear? Okay, we are going to study about in detail. We are going to study about Einstein's theory first. Next, we are going to study about the interference, diffraction, and polarization. Okay? I think you people are clear about the introduction part. Still now, what I discussed, this will be only introduction part. Clear?